We're not gonna get this.
Today, we are going to go back to section 2.1, and we are going to review how to solve these awful-looking equations. Look at this one, absolute value. These are gonna be really difficult. The ones you did on your test yesterday were a lot easier. Those were tended to be done without a calculator. These ones, if you flip to the very, very back, I want you to kind of look at all the different kinds of equations that we will deal with. We've got radicals, we've got polynomials to the 4th, 5th, 7th power, we've got quotients, we have absolute values mixed with polynomials. You're going to be able to solve all of these equations using the graphing calculator. So why didn't we use a graphing calculator yesterday on your test?
Illegal.
Because we want you to use your brain.
I don't want to.
Okay? We want you to understand the process involved in solving each type of equation. Now we're going to do the same thing, but I'm going to show you how to use the calculators. These kinds of answers are going to be ones where you're going to want to use the calculator because they're going to be irrational numbers. Now, can they turn out to be integers? Absolutely. But these ones are going to be mostly those decimals that go on and don't end. They're irrational numbers for the most part. Okay, are we good? So now, do you remember when we did, when we solved a quadratic equation, what were we looking for? So like, for example, if I gave you x squared, this is going to be really easy. If I gave you this problem, if I asked you to graph this, what would it look like? It's really easy. It's a parabola. And where it hits the x-axis, which would be -2 and 2, right? And how did we get that? I just did it in my head. If you factor x minus 2, x plus 2, and you set each of these equal to 0, 2 and -2 are called your roots. Those are the solutions. So what does this mean? It means if we plugged -2 in here and squared it and subtracted 4, we'd get a 0. And same with 2. These are the two numbers that make this work, right? Well now, what if I give you something like x squared minus 5? Okay, can you factor that? No. But I can show you how to do that on your calculator and get where it hits the x-axis. It's going to be plus or minus √5, right? So now, just think of that whole test that you took yesterday. I'm going to show you how to get these answers. Now there's two methods involved in solving these. One method is called the intersection method. The intersection method is used in a problem. You could actually do this on anything that has something equal to something else. You're not going to want to use this method if the problem is set equal to 0. So when you have two equations, there's an equation right there, or I should say polynomial, there's another one, expression. When they're set equal to each other, we can use the intersect method. The intersect method is looking at where the left side meets the right side. So what you're going to do, I'm going to teach you on the old calculator, because a lot of you guys have these. On your old calculator, on your 83s, or if you have an 84, I want you to type in y1. And I want you to type on the left side under y1, you're going to type absolute value of x squared minus 4x minus 3. So how do you get absolute value on this calculator? Math, num, abs. And then type x squared minus 4x minus 3. And then end your parenthesis. Everybody have that? No?
There were no more calculators.
Can you share? Look at all batteries are dead.
Yeah, mine is not.
Here.
It's not. I'll watch, I'll pay attention.
Can you, yeah. Okay, now, when you hit graph, that corner button down there, what that is, these are all of the ordered pairs that satisfy this relationship right here. Okay, that's what that graph is. Now, what you're going to do is go to Y1, and you are going to hit, under Y2, you're going to type in the second expression, which is x cubed plus x minus 6. And when you hit graph, you're going to see a cubic function. We have some prior knowledge of what that cubic function looks like, and here it is. Now, what you're looking for, you should see this picture. I have it printed for you on right here. That's what you should see. Now, if your window is goofy, you're going to want to change it, hit window, and make sure you're in a standard window right now, because that's where I am, standard window. Okay, 10 by 10. Okay, so that was the first equation, and here's the second one. So now what you're looking for is where these two graphs intersect. It's that point right there. Now, instead of doing the algebra, we're going to use technology. I'm going to show you how to find out that x value. So you're going to hit second, calc. Now, these are all the things that it could calc, the maximum, minimum. I'm not going to find the 0. The 0 is where it hits the x-axis. I want to know where these two intersect. So hit 5, or scroll to 5 and hit enter.
Does somebody want this? Because I can use the Inspire.
You what?
I'm just going to use Inspire now.
Okay. Okay.
Somebody want this?
Does anyone want that? So I want you to trace as close to you can where that is intersecting. And then hit enter 3 times at the bottom. Enter, enter, enter. And what will pop up is the x value where these two intersect. So in other words, 2.2, and it's a bunch of other numbers, but I'm just going to chop it off right there at 2.2. 2.2 is approximately the answer. So in other words, if you plug 2.2 in here, 2.2 squared minus 4 times 2.2 minus 3, take the absolute value of that, it's the same as 2.2 cubed plus x minus 6. Isn't that amazing?
Yes.
Now, there's another method, and it's called not the intersect, but the intercept. And that is on the back side right here, the intercept. Now, what is an x-intercept? We're going to still do this problem. I'm going to show you get the same answer. I'm going to show you on the same problem. The x-intercept method, you are going to set this equal to 0. So what you have to do is move these 3 pieces on the other side. And you're going to type under Y1, you're going to type all of this, but you have to move these 2, and you don't have to do it with pencil, but I'm going to show you what you're going to type in your calculator. So on your calculator, I want you to go back into and clear out those equations. So go to Y1, and you're clearing it out. And under Y1 or Y2, doesn't matter where you're at, I want you to type in the absolute value, so math num abs, x squared minus 4x minus 3, absolute value, so parenthesis, and then minus x cubed minus x plus 6. Now, why am I changing these to a negative and a negative and a positive? Why am I doing that? Anyone know why? When you move something over, what are you doing? You're adding the opposite of it. So I want you, on your calculator, everyone should type in absolute value, so math, num, abs, and then we have x squared minus 4x minus 3, parenthesis, minus x cubed, minus x, and then plus 6. And I want you to hit graph. Now what you're going to see here, that's the graph of the whole thing set equal to 0. If you set it equal to 0, what you're looking for is where the graph hits the x-axis. We're looking for the x-intercept. Now how do you do that? You're going to go to second calc, and you're going to calculate the 0. The 0 is your x-intercept. So go to 0. Now they're asking you, I want a left bound. So here's your graph. Here's the solution. It's somewhere between 2 and 3. Can you give me an integer that is to the left of where it's hitting the x-axis? 1. I like 1. So you're going to type in, it's asking you, left bound, question mark. So you're going to type in 1. Now it's asking you for a right bound. Can you give me a number to the right of that intersection where it's hitting the x-axis? 3. Sounds good? Now it's saying, hey, want to guess? Yeah, we don't want to guess, so just skip that and hit enter again. And bam, what answer do you get? 2.2. It's the same number that you got when you did the x-intersect method. Okay? Yes?
I only got to like, what did you do to get there?
Did you hit second calc,
Yeah.
okay? And then did you go second calc, then did you go to 0? Whoops. Second calc, 0. Okay, now it's saying left bound. Make it 1, or you could use 0. Then the right bound, I'm going to say 3. Hit enter. We're not going to guess, so we're going to hit enter again. And there it is. You have it?
Got it.
Okay, good. Now, let's try this on the Inspire. On the Inspire. Now, on the Inspire, I prefer the x-intercept method. I prefer to get, it's clearer for me to see where the graph hits the x-axis than to see where they intersect. Okay, so I want you to go to new graph, new document, and we're not going to save my old one. So go to add a graph, and this is where you got to type in your equation. We're going to type this in again, and I'm going to show you how you get the same answer using the Inspire. What's nice about the Inspire, it's clearer when you see the pictures, the pixels, everything's just nicer
How'd you
on
get to write
this.
the equation?
Say it again.
How'd you get to write the equation in?
Press tab.
Can you help her? I go to new document, and I do add graph. That's how I go to it.
Okay.
Okay? Now, how are we going to type absolute value? Because it's not math num anymore. It's different. You're going to hit this button right here. Hit that button, and up pops up a bunch of boxes. There's your absolute value button. Who's lost? Who's lost? Anyone?
I don't know what button you pressed.
Right here, right here. Here, I'll point to it on this poster. Can you see it right there? Hit that button. Now, do you see the absolute value one?
Yeah.
Okay, hit that. And the more you use this calculator, the better you'll get at it. So now I want you to type in x squared. Now where's the x button? Right there. There's x. X raised to the second power. I wish I could make this bigger. And then keep typing the equation. Minus 4x,
You have to arrow down.
oh, yep, she's right, I have to arrow down, see? I have to arrow down 4x, thank you for catching that. And then minus 3. Now that's the absolute value part. How do I type the rest in?
Push over.
You have to arrow over, get outside of that absolute value, and type the rest in. What's the rest? Minus x cubed, and then arrow down, minus x, and then plus 6. So I am typing, I'm setting this equation equal to 0. Now, does everyone have that equation? Now hit enter. And it's going to graph it for you. Now, we don't have the whole picture, but really all we're looking for is that answer right there, where it's hitting the x-axis. So now how do you calculate that number? Because it's not 1, it's not 2, it's somewhere between 2 and 3. So what you're going to do is hit menu. Menu. Everyone have the menu button? And you're going to analyze graph. And what do you think we're looking for? The 0. Hit that middle button. Now look what it asks us. Lower bound. So here is the graph of it. Can you give me a number to the left of it?
2.
Left.
1.
1. You could say 2, but 2 is really close. Let's do 1. And then hit enter. See how it popped up? Hit enter. And look what it did. On my calculator, it shaded that region. And what do you think that 2.1 comma 0 is? That's the intersection. And now if you hit enter again, there it is. There's your 0. 2.21 comma 0. Which calculator do you like better? You like the Inspire? Okay. So, if you have an 83 at home and that's what you're planning on going to college with, and you know, money's tight, you may want to stick with the 83, and especially if you're taking the ACT test and you want practice, we can't lend these Inspires out. They can't leave here. Okay? So the 83s are more accessible to you than the Inspire. So it's really a matter of what you're going to be more successful with between now and when you go to college. I want you to, you know, you might want to be versatile and be able to do both of them. But notice the keystrokes are kind of the same, but they're a little different. So use what's best for you. And I will help you with either calculator, okay? So let's go and go to the back side. Okay, now, this one, example 2, is asking you to use the x-intercept method. Now use the calculator you feel more comfortable with. I'm going to use the Inspire. I want to get out of my comfort zone. I want to use the Inspire as much as possible. I want to get good at this. This is the Cadillac of calculators. So what I want you to do is I want you to clear out your equations. So I'm going to go to New Document. I don't want to save that one I have. I want to clear it out. And I'm going to add a graph. So I like to make sure that it says F1.
How do you make it say
Are you good?
Yes, I did.
You're good?
How do you make it say F1? Press tab. I did. Never tab 2.
Arrow up. You got it?
It's
Thank you. All right, now, I think the easiest way is the x-intercept method. It's clearer. I'd rather look at where a graph hits the x-axis than, I want you to see something like this. Flip to the next page. Sometimes your graphs are going to look really ugly, like that. Do you want to sit and find out where this thing hits, crosses, intersects? No. So you may need to stick with one method, which I think the x-intercept method is the easiest method. So I want you to take your calculator, and if you're using the Inspire, you're going to type in, and I know this is hard to see, I'm going to blow it up. It says x to the 5th plus x squared, and then what would you type in? Minus x cubed minus 5. Now, someone in second hour asked me, do you have to organize this? No. You do not have to put them in standard form. You don't even have to write what I wrote. This is basically a calculator activity. So I want you to type in x to the 5th, x to the 5th plus x squared.
Can you put your calculator on the screen?
Oh yes, I'm sorry.
We have to put it on the screen.
I don't want this.
X to the 5th plus x squared minus x cubed minus 5. Whoops, see what I did again? You gotta arrow down, x squared, and I do that often on this. X cubed minus, you gotta arrow down. So I take a second to make sure it's typed in correctly. Is it? Am I good? Now what am I gonna hit? Hit enter. Where's my enter? Enter is down here, right there. And guess what we have? There's the graph. Now I want to calculate the 0. So go to menu, and I want to analyze my graph, and I want to find the 0, and it's asking me lower bound. Give me a number to the left of, that looks like it's between 1 and 2. You could type 0, you could type 1. I'm going to type 1, and then hit enter. And bam, there's your answer. And you could hit enter again, and it's going to pop up as a black dot. 1.420. So in other words, 1.42 approximately, if I raised that number to the 5th power and I added the square of that number, it's the same as cubing that number and adding 5. Okay? Now, there are, you know how many equations you've been solving over the last how many years? You could do this on anything. But there's a few issues that arise. Look at the next problem. When you have a radical set equal to 0, only set equal to 0, what you do is take what's underneath it. Don't type in the radical. If you do, what's going to happen is you're going to get you want to find out where this is equal to 0. If you type in the square root of all this stuff, your graph will not cross the 0, it will not hit here, and you won't be able to see where it hits. So in a case like this, when you have a radical, you're just going to set underneath it, only when it's set equal to 0, you set the x to the 4th, and by the way, this is hard to read, I understand, these are all in your book though. You're going to set x to the 4th, that's a plus sign, x squared minus 2x minus 1. You're going to set that equal to 0. Do not use the square root because it's not going to give you the picture. So I want you to try this one. Again, new document. No, I'm not saving this. I'm going to add my graph. I'm going to type in on my calculator. I'm going to type in x to the 4th plus x squared. Whoops, see how I do that all the time? So you got an arrow down, x squared. Arrow down, minus 2x, and then minus 1. And then hit enter. We're gonna graph this one. And there's, how many answers are there? There's 2. Let's go with finding the furthest, the smallest one. So which one's that one? That right there. So what am I gonna hit? Menu, analyze graph, in 0. Okay, it's asking me lower bound. I wanna go for this one first. So what number do you think is to the left of that? -1. Let's type in -1 and then hit enter. And there's our first one. You can hit enter again.
Why doesn't do that?
It doesn't do that?
Like it doesn't tell me. Oh.
It's,
Oh wait, never mind.
do you see it?
Yeah.
Okay. Now, so that's one answer. It's -0.405. How do you get the next answer? You hit menu, analyze graph. We want the 0. And it's asking me lower bound. What are you gonna put now?
1.
You could put 1 or you could put 0. Let's do 1. Hit enter. And then enter again. Bam, what is it? Now this is where I have a hard time, is picking up this and moving it. Can you guys see it?
If you just click on it.
It's 1, I don't know why I can't.
Press the back arrow, the
Back
escape
arrow?
button. Okay, and now put the cursor over it and hold down the middle button.
Come here. You can do it. See,
Now
I
press-
always
now
thought
press
you're
it.
supposed to hold that.
No.
No. So go ahead. We have a professional. Okay. See, there she goes. You guys are more, these are better. Yeah. That's the word. There you go. Questions? Okay, let's keep going. And by the way, on the top, I showed you what the graph looks like. Now, for this one, example 4, if you were to plug this whole thing into your calculator, this is the ugly picture you would get, which is really hard to see. So what you're gonna do, we learned that if you have a fraction set equal to 0, the numerator must be equal to 0. So all you have to do on this one is set 2x squared plus x minus 1 equal to 0. But the thing is you have to make sure that that answer will not satisfy the bottom because it's undefined there. But we're not gonna go there. We're just gonna stick with finding the zeros of the numerator right now. So let's go to add a graph. Okay, we're gonna set 2x squared plus x minus 1. And hit graph, or hit enter. And there's your, so what are you looking for? You're looking for these two solutions right here. So how are you gonna find the first one? Menu, analyze graph, And we're gonna find the 0. In lower bound, I'm gonna hit -2. And there it is, there's 1. And then to find the other one, you do the same thing. Menu, analyze graph, 0. And that one looks like it's between 0, enter, and there it is right there. I still have a hard time moving it.
There you go.
It's, so what answer is that? It is 0.5. Okay? Now, the back side is your homework. In 1 through 5, it says do not solve these ones. I just want to know how many solutions there are. They're not asking you to figure out what they are, they just want to know how many there are. So, does anyone think they know a good way to do this? You could look at your exponent, but what does that mean? I knew someone was gonna say that. This says, by the way, I think, is it x to the 5th?
Fifth, yeah.
Okay, let me make it bigger. X to the 5th. So, we learned last year that the highest exponent, or the degree of the polynomial, tells you at most, there's 5 solutions. Does that mean that there are 5 solutions? No. Because let's consider a parabola. If I gave you this problem, how many solutions are there? There's none in this one. Now, what's the most there could be?
2.
There could be 2. There could be 1. So, when you have an x squared problem, at most there's 2, but there could be none, there could be 1. So, what does this mean? That means at most there's 5. But how many are there? So what you're going to do is do what? You're going to graph it, and you're going to look for the left and right behavior, and you want to make sure that you see enough of this graph that you can tell how many times the graph hits the x-axis. Do you guys remember odd? One side's going to go up, the other side's going to go down. So I'm not getting into that yet because we're going to go deeper into that stuff in chapter 3. So I just want you to basically type this in and check out how many times this thing hits the x-axis. I wouldn't do the x-intersect method. I would type this into like this, x to the 5th plus 5 minus 3x to the 4th minus x. I would type that in and tell me how many times you see the graph hit the x-axis. I'm going to type this on the old calculator.
Can you do it in English so I can see?
Huh?
Can you do it in like the thing so I can see it?
In the what?
Like so in school so I
Yes.
can see it?
Yes. I'll do both calculators. X to the 5th plus 5 minus 3x to the 4 minus x. Now when I hit graph, now look at this. My left and my right are going up and down. Remember how we learned that last year? So how many times do you see this thing hitting the x-axis?
3.
So guess how many solutions there are? 3. Now, are they asking you what are they? No, they just want to know how many there will be for this one. So this one is 3. The answer to this one is 3. How about number 3?
Start.
And you could do the same thing with the Inspire. How many at most are there? 7. Does that mean there are 7? No. There might be. Minus 10x to the 5th.
One, two, three.
Yep, I see 3. Now we could, you might think, well, maybe there's more.
No.
You could change your window and expand it, but there's only 3 on this one. So how do you change your window? You can move it, you can change these numbers around on this calculator. I could go by 100. I could do 100 and change these going by 10. You can do whatever you want. The only thing is the more you do, it's gonna be really, really scrunched in and hard to read. So I would change, in other words, you know what this means? That means each box is going by 1s. So if I'm gonna bump this up to 100, I'm gonna wanna make each box like 5 or 10. So it's counting by 5s. That's what these two are. Your X and your Y axis are counting by that number, okay? So how about number 5? How many does that one result in? How many? I got 2 for this one. 2 solutions. Now the rest of these, I'm going to give you time now to work with the calculator. And I have the answers all up here. It's your job this hour to type these all into your calculator. And I want to make sure that you get the same answers that I got. If you don't, I want you to raise your hand. I want you to ask your neighbor. You need to be able to do this because on your test, I cannot tell you what to hit. You're going to be tested on these. You got to be able to use your calculator, okay? Now just to warn you, question 15. You want to type this in your, is this set equal to 0? No. You're going to type this in as x squared minus the square root of x plus 5. And you're going to find out where it hits the x-axis. Whereas 13 and 11, why are they different? See if you remember what I told you before. Yeah, you just set underneath it equal to 0. So when you have one radical set equal to 0, you only take what's underneath here and find the 0 of that. Only underneath, under the radical. But in a case like this is not set equal to 0. It's not like it's one radical. This one you're going to type the whole thing. Okay? So here, I want you to find the zeros. And I'm going to leave this up. Can you hit stop the record?